Hey, Wagwan. Yeah, man. It's Mr. Garthrid here. And today we'll be looking at a CAPE integrated mathematics question. All right, I'm focusing on module 1, that is foundations of mathematics, and I'm focusing on the trigonometry section of the syllabus. Okay, so I have 3 questions prepared for you. All right, these are exam type questions. Okay, and I've looked in your syllabus many times, so I know the types of questions that they can ask in the exam. All right, so question 1 here is going to focus on finding minimum and maximum values of trigonometric functions. Question 2 is going to be focusing on a trigonometric graph, and question 3 is going to be focusing on finding some unknown values in a trig function, all right, which also involves amplitude and other things. Okay, and at the end of those 3 questions, we're going to do a 4th question, which is going to be a multiple choice question from the 2019 past paper on trigonometry. Okay, good. So to start the first part of the question here, we want the minimum and maximum value of the function 1 plus sine x. Okay, now what do you know about the function sine x? Well, you should know that the values of sine x must be greater than or equal to -1, but less than or equal to 1. All right? And what that means is basically when you plug in a value for x, all right, for sine, you will never get a value outside of this interval. Okay? You're not supposed to get a value outside of this interval. All right? So the values of sine x is greater than or equal to -1, but less than or equal to 1. That's something that you have to know from the sine graph. Okay? Good. Now, remember that this is what I want here. All right? I want to know the minimum value of 1 plus sine x. Now, if I tell you that the sine x is greater than or equal to -1, but less than or equal to 1, that basically means that the minimum value of sine x is -1, and the maximum value of sine x is 1. Okay, good. And I need to know the minimum and maximum value of 1 plus sine x. So how am I going to get that now? Well, what I'm going to do is to just manipulate this inequality. Okay, so what I'm going to do is I'm going to add 1 to both sides of the inequality. Okay, so when I add 1 here, I'm basically going to get 1 minus 1, right? Or -1 plus 1, same thing. Less than or equal to, I'm adding 1 here as well. So that will give me 1 plus sine x. Okay. Less than or equal to, I'm adding 1 here as well. So that's 1 plus 1. All right. I hope that was understood. So now you see that I have 1 plus sine x in the middle there, which is what I wanted. Okay. So let us now simplify this. 1 minus 1 is 0, less than or equal to 1 plus sine x, less than or equal to 1 plus 1, that's 2, right? Great. So what is this saying now? We have 1 plus sine x greater than or equal to 0, but less than or equal to 2. All right, so what this tells us is that the maximum value of 1 plus sine x, all right, that's the notation that we use to put max and then the function inside the brackets. So the maximum value of 1 plus sine x is going to be equal to this number right here. Okay, that's 2. All right, and the minimum value of sine x, of 1 plus sine x, sorry. All right, so that notation is min, and then the function in brackets. So the minimum value of 1 plus sine x is going to be equal to this value here. Okay, 0. So that is what the question asks us for. The maximum value of the function is 2, and the minimum value of the function is 0. Okay, so we have now completed part 1 of the question. We're now going to do part 2, which is 5 sine x minus 3. right? 5 sine x minus 3. So this is number 1, part 2, solution. Okay, so we have 5 sine x minus 3. Now remember that the range for sine x, all right, that's greater than or equal to -1, but less than or equal to 1. Now in the middle here where I have sine x, I want to have 5 sine x minus 3. Okay, that is my aim. So let us try and manipulate this inequality. All right, so first what I'm going to do is to put the 5 beside the sine x, right? So what I'm going to do is to multiply the inequality, sorry, by 5. All right, and if I do that, I will get 5 multiplied by -1 less than or equal to 5 multiplied by sine x, and that must be less than or equal to 5 multiplied by 1. All right, now we don't have to change the sign of the inequality here because we're not multiplying by a negative number. Okay, so if we were to multiply by a negative number, it means that the inequality sign would have reversed, right? It would have changed. So we're good here because the 5 here is positive, all right? So 5 multiplied by a -1 is -5, and that is less than or equal to 5 times sine x, that's 5 sine x, less than or equal to 5 times 1, that's 5, okay? So what this here is saying is that the minimum value of 5 sine x is -5, and the maximum value of 5 sine x is +5, okay? But remember, I don't want 5 sine x, I want 5 sine x minus 3. So in order to get the minus 3 in the middle there, what I'm going to do now is to just subtract 3, all right? I'm going to subtract 3 for each term. So I'm now going to say -5 minus 3 less than or equal to 5 sine x minus 3 less than or equal to, I'm going to subtract 3 from here as well, so that's 5 minus 3. Okay, that is what I have. Great. Let us now simplify. So that's -5 minus 3, which is a -8. Okay, -8, and that is less than or equal to 5 sine x minus 3 less than or equal to 5 minus 3. We know that is 2, right? Good. That's 2. Now that is what I wanted, right? I have 5 sine x minus 3 in the middle there, which is what I wanted. So what is that saying now? This is saying that the maximum value of 5 sine x minus 3 is equal to this value here. All right, that's 2. And the minimum value of 5 sine x minus 3 is equal to this value here, which is -8. Okay, good. So we have now completed the second part of question 1. All right. So we're gonna do one more. All right, with this one here, it's cos, right? So we have 3 cosine x plus 1. All right, let's do part 3 solution here. So this is now number 1, part 3 solution. Okay, so we had 3 cosine x plus 1 in the question, all right? Now, what do you know about the cosine graph now? Okay, so you should know that the cosine graph is also greater than or equal to -1, but less than or equal to 1, just like the sine graph. Okay, so the values of cosine x must be greater than or equal to -1, but less than or equal to 1. All right, just like the sine graph. Okay, The only function that doesn't behave like that is the tan graph. Okay? Because the tan graph doesn't really have an amplitude or a height, right? Okay, so let us manipulate this now. I need 3 cosine x plus 1 in the middle here, where I have the cosine x. So I'm gonna try and see if I can put the 3 there in front of the cos x in front, all right, by multiplying the entire inequality by 3. Okay, so let me just put it to the side. We want 3 times the cosine of x plus 1. That's what I want, all right? So to get the 3, what I'm going to do is to just multiply the entire inequality by 3. So if I do that, I will get 3 multiplied by -1 less than or equal to 3 multiplied by the cosine of x less than or equal to 3 multiplied by the 1. Okay? And I can just simplify this now. So 3 times -3, 3 times -1, sorry, is a -3 less than or equal to 3 times cosine x, that's 3 cos x, less than or equal to 3 times 1, that's 3. Okay? So what this here is saying is that the maximum value of 3 cosine x is plus 3, and the minimum value of 3 cosine x is minus 3. Okay? But remember, I don't want 3 cosine x, I want 3 cosine x plus 1 in the middle here. So I'm now going to add a 1 to the inequality. All right, so I'm now going to say -3 plus 1 less than or equal to 3 cosine x plus 1 less than or equal to 3 plus 1. All right, and clearly you can see that I now have that there, right? 3 cosine of x plus 1. Good. So all I have to do now is to just simplify this so that I can find my minimum and maximum values. So -3 plus 1 is a -2 less than or equal to 3 cosine x plus 1 less than or equal to 3 plus 1, that's 4. Okay, good. So that is what we have. So what this now here is saying is that the maximum value of 3 cosine of x plus 1, all right, that is going to be equal to this value here. All right, that's positive 4. And the minimum value of 3 cosine of x plus 1 is going to be equal to this value here, which is -2. Okay? And that is my solution for this part of the question, part 3 of question 1. All right? So I hope you understood. Okay? I hope you understood how I did the questions. All right? And of course, if they put a question like this in this year's exam, all right, whichever year you're doing the exam, then you should get it, right? Because it's very simple. All right, so with practice, you will get it. Okay, so we're now finished with part 1 of the question, with question 1, sorry. So we're now going to do question 2. Okay? Yes, so we're now back with question 2, all right, which is a graph question. Okay, it says that the graph of the trigonometric function f of x equals m sine x plus n is shown in the diagram below. Okay, so I did the graph for you here. And it says determine the values of m and n and write the equation of f of x. Okay, this is also another type of question in which they can ask in the exam. All right, so you have to know how to do these types of questions. Okay, I remember doing a past paper question similar to this. Okay, and if you haven't watched that already, it will be in the playlist at the end of this video. Okay, so we have to determine the values of m and n and write the equation of f of x. All right, so first of all, what does m represent? All right, what does m represent and what does n represent? That is the first thing. All right, that's the first thing that we need to know. So M here, all right, M here represents the amplitude. Yes, so M represents the amplitude of the graph, all right, of the waveform, and N represents the vertical shift, okay, and represents the vertical shift or the y-intercept, all right? So let us find the value of M first, okay? That is the amplitude, okay? So this is number 2 solution, all right? So we're gonna do M first, all right? What does M represent? M represents the amplitude, okay? So M is the distance from the rest position, okay? The maximum height from the rest position. What do I mean by rest position? Basically where the graph starts, all right? You have to look for the axis where the graph starts. Now you see this dotted line here, all right? And that dotted line represents where the graph actually starts, okay? So this is what we call the rest position, all right? I believe in physics they refer to it as the undisturbed position as well, okay? Good. So we want to know the maximum height of the graph, all right? That is our amplitude. So we're talking about this distance right here, okay? That distance right here. So let me just fix this a bit. Okay, good. So how many units is that now? Well, if I am at -3 and I want to go up to -1, all right, then that would be 1 unit, 2 units, okay? So this is 2 units, all right? So it means that my amplitude is 2 units, okay? And the same height up would be the same height down, all right? So what that means is that if I want to go from -3, all right, from the rest position here to -5, I would have to do how many units? It would be 1 unit, 2 units, right? So it's also 2 units. So 2 units up, 2 units down. So it means that my amplitude or the height of the graph is 2 units. Okay? I hope that was understood. So the amplitude M, okay? So the amplitude M is equal to 2 units. All right? So we have now calculated the value of M. Let us now find the value of N. What does N represent? Now you can look at N in 2 different ways. All right? You can look at it in terms of a transformation, or you can look at it in terms of the y-intercept. All right? So let's look at it in terms of the y-intercept first. So the y-intercept basically means where the graph cuts the y-axis. All right? And clearly you can see that the graph f of x here cuts the y-axis at -3 on the y-axis. All right? So it means that n is equal to -3. Okay? Another way you could look at it is in terms of the vertical shift. So if you remember the sine graph, right? If you remember the sine graph correctly, you should know that it starts at what? It starts at 0. Okay? So let me just do a sketch here of the sine graph. All right, so it's gonna go through 0. It's gonna go through 0, then -1, then pi, all right, then -1 here, and then 2 pi. Okay, that is a sketch of the sine graph, y equals sine x. All right, so if you're looking at it in terms of a vertical shift or a transformation, right, we're talking about the distance from 0 to -3. All right, how many units would I move from 0 here to -3? All right, so let me just draw an arrow so that you can understand it clearly. All right, so let me draw the arrow here. Right, so we're talking about that distance there. Okay, that is the distance that we're talking about. So if I move from 0 to -3, I would have to move how many units? Let's count. 1, 2, 3 units down. All right, so 3 units down. Okay, good. So I can now say that the amplitude is m equals 2 units, and the and f of x, right? And f of x has a vertical shift, of 3 units downwards. All right, it has a vertical shift of 3 units downwards. All right, so that means that the value of n is not equal to 3 but -3. Why? Because we're talking about downwards. All right, it is shifted downwards, so it means that the value of n is -3. Okay, so that is one way you could look at it, or you could look at it in terms of the y-intercept here. All right, you see that the graph cuts the y-axis at -3, so the value of n is -3. All right, so that is my value for m, and that is my value for n. Now, please note that the value for n might change depending on the graph that you're given. All right, so if it is a vertical shift, it means that it can either shift upwards or it can shift downwards. All right, I believe in the past paper question that I did for a question similar to this, it had a vertical shift upwards. So that is the reason why the constant at the end was positive. All right, but because this has a vertical shift downwards, all right, it means that we're moving downwards. So it means that our value is going to be negative. Okay, so the value of n is -3. All right, and it says that we are to write the equation of f of x. So I can now say that therefore f of x is going to be equal to, they told us that it is equal to m sine x plus n. All right, so therefore f of x is equal to m, which is 2, sine x plus n, which is 3, right? So sine x plus n, which is -3, sorry. Okay, so that is my function f of x. Great. So we have now completed the second part of the question, and I hope that it was understood. Okay, we're now going to do another type of question. All right, question 3. All right, which also focuses on trigonometric functions. Yes, so we're now at question 3, which says the function g of x equals a cosine bx, sorry. All right, g of x equals a cosine bx, has an amplitude of 5 units and period 2 pi radians. State the values of a and b and write the equation of g of x. Yes, so this is our question, all right, guys? The function g of x equals a cosine bx, has an amplitude of 5 units and period 2 pi radians. State the values of a and b and write the equation of g of x. All right. So we're now going to do this question. Okay. Now, this is also another way in which they can bring these types of questions. All right. This is another way they can bring these types of questions into your examination. All right. So instead of giving you a graph, they can put it to you in words like this. Okay. And you have to know what it means. Okay. So this is now question 3 solution. So we're going to calculate A. All right. What does A represent now? A represents the amplitude of the graph of the waveform, right? So we can now say that the amplitude A is equal to what? They already told us that the amplitude is 5 units, right? So we can say that the amplitude A is equal to 5 units. All right? Good. So we're basically finished with A. Let us now calculate B now. All right? Now, this might be a bit tricky for some students. All right? How do you calculate B? Okay? How do you calculate B? Well, what does B represent? You should remember that B represents the number of cycles in the waveform. All right? The number of cycles. So in order to calculate B, you would have to know your knowledge of the period. Okay? So there is a formula that we use for the periodic time, or the period for short. All right? So the periodic time, capital T, is equal to the period of the periodic time T is equal to the period of the original graph. All right? So the period of the cost graph, you should know that is 2 pi radians. All right? 2 pi radians divided by B. Okay? That is what we call the periodic time. All right? The periodic time. Good. So they normally use capital T in physics. So that is the notation that I'll be using here. All right? So the periodic time is equal to 2 pi over B. Okay, good. So what do we know about the period now? In the question, it says that the period is 2 pi radians, right? So what it means is that T is equal to 2 pi radians. All right? That is what it means. So I need to know, use that information to find the value of B, all right, which is the number of cycles. So if I know that T equals 2 pi over B, and they told me that T equals 2 pi, then it implies that 2 pi must be equal to 2 pi divided by B. Right? I hope you can understand that. Right? So 2 pi over B must be equal to 2 pi. Right? Because both of these are the same thing. So I'm now going to find the value of B. So what I'm going to do is to put this over 1, right? That's the same thing as 2 pi. And then I'm going to cross multiply. All right? So what I now have is 2 pi being multiplied by B, all right, equals 2 pi multiplied by 1, which is 2 pi. Okay, good. So in order to calculate the value of B, all I have to know is to just get rid of this 2 pi by dividing both sides of the equation by 2 pi. All right? So if I divide the left-hand side of the equation by 2 pi, I will get B on the left-hand side of the equation. And I'm now going to divide the right-hand side by 2 pi. All right? So 2 pi over 2 pi is 1. So the value of B is equal to 1. Okay? So we have now calculated the value of A and the value of B. All right? And it says that we have to write the equation of g of x. So it told us that g of x, all right? So therefore, g of x, okay? Yes, so we now have the value of A and B. So we're now going to write the equation of g of x, that's A cosine bx, all right? So g of x equals A cosine of bx. All right, and that is equal to, so therefore, g of x equals a. A was 5 units. All right, so that's 5 times the cosine of bx. B is 1 times x, so that's just 1x. All right, but we don't really write the 1, so that's just x there. Okay, so g of x is equal to 5x. All right, and that is the end of question 3. Okay, so I'm now going to do question 4, which is a past paper question from the 2019 paper, right? Multiple choice paper. Yes, so we're now at the last part of the question, all right, which says that which of the following trigonometric graphs represent y equals tan x for x greater than or equal to 0 but less than or equal to 2 pi. All right, so this is from the 2019 paper 1. All right, so this is a past paper question for trigonometry. So which of these trig graphs is tan x for x between 0 and 2 pi inclusive? Okay, now we're going to rule out some of these answers here. All right, because obviously we know that only one answer here is correct. So we're going to rule out the answers that we know that is incorrect. Okay, so let's do that. So first things first, you should know that the graph of tan x, all right, is a discontinuous function. What does that mean? It means that it has break in the graphs. All right, it is not a connected curve. Okay, so the graph is broken into separate pieces. All right, it is discontinuous. So it means that I can rule this out. All right, that is not the graph of tan x. I can also rule that out. Right, that's not the graph of tan x either, because those two graphs are continuous functions. All right, they don't have breaks in the graph. All right, you see these lines here. All right, these vertical lines here, that indicates that the graph is actually discontinuous. All right, and of course you can see that if I want to draw the other part of the graph, right, once I draw this part of the graph here, in order to draw the other part of the graph, I'd have to lift up my pen or my pencil to draw the other part of the graph. All right, that's basically an intuitive way of what the concept discontinuous function means. Okay, good. So I've now ruled out the function that I know that are not a discontinuous function, right? So those two could never be tan x. Okay, now the other two remaining indicates that one of these is tan x, right? Because both of those are what? Both of those are discontinuous functions, right? Good. So it's kind of tricky, right? Because you probably might be saying, both of those look similar, which they do, right? But only one of them is indeed the graph of tan x. All right? Okay. So if you want to know which one is the graph of tan x, all you have to do is remember one simple thing. One simple thing. And that is where the graph is discontinuous or where the graph is undefined. All right? So tan x is undefined, all right, or discontinuous when our angle x is equal to pi over 2 radians plus n pi. You must know this, where n is a member of the set of integers. Okay, that's something that you must know. So the graph of tan x is undefined or discontinuous when x equals pi over 2 plus n pi. Okay, where n is a integer. All right, meaning negative numbers, negative whole numbers, positive whole numbers, including 0. All right, so when n equals 0, all right, it means that we're going to be left with what? X equals pi over 2, right? So we know that at x equals pi over 2, the graph is going to be undefined there or discontinuous there. right? Let's look at the graph of B. Clearly, you can see that the graph is discontinuous at x equals pi over 2, right? You can see the vertical line right there, the vertical line, which is dotted, okay? And that is really what we call a vertical asymptote, all right? That dotted line that you see is what we call a vertical asymptote, all right? And anytime you see a vertical asymptote like that, it means that the graph is discontinuous at that point, all right? So at x equals pi over 2, we have a horizontal asymptote, which means that the graph is discontinuous or undefined at that point, okay? Good. So if you look at D, you can see that the graph cuts through x equals pi over 2, right? So for this graph in D, at x equals pi over 2, it is defined, right? But remember that our graph at tan x, all right? Remember that our graph at tan x must be undefined, okay? Or discontinuous when x equals pi over 2 plus n pi. So it means that D is not my answer, A is my answer, all right? Because at A, I know that it must be discontinuous at x equals pi over 2, okay? Good. Now, when n equals 1, all right, so we're looking at this. When n equals 1, pi over 2 plus pi is going to be 3 pi over 2. So it is also going to be discontinuous or undefined when x equals 3 pi over 2. And clearly in the graph of B here, you can see that it has a vertical asymptote at x equals 3 pi over 2. All right, so the graph can't touch there. Okay, the graph can go close to there. All right, it can go as close as possible, but it will never touch. Okay, good. So it means that B is my answer for this past paper question. All right, and that is the end of this session on trigonometric graphs. All right, so you have to know these stuff about trigonometry because they can pop up any of these types of questions into your exam and you have to know how to answer them successfully. All right, so I hope it was helpful. If it was, please ensure to like up the video and subscribe to the channel. Okay, I'm Mr. Garth Reed, student ambassador in the University of Technology, Jamaica, and I'm also a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.